Hello, we'll discuss some examples. Determine the number of equilibrium points for the system. With the equation given for the system x1 dash is equal to x2 and x2 dash is equal to x1 minus x1 cube. So prima facie we can say that there are three numbers of equilibrium states because this is a third order system, but we have to determine. So as at equilibrium points, what we can say at equilibrium points x1 dash is equal to 0 and x2 dash is also is equal to 0. So if you put here x1 dash is equal to 0, then this x2 is equal to 0 and this x1 minus x1 cube, this is also is equal to 0 according to this definition. So therefore equilibrium points for this is if you take here x1 common, we'll get here 1 minus x1 square is equal to 0. So x1 is equal to into 1 plus x1 into 1 minus x1 is equal to 0. So there are the solution x1 is equal to 0 minus 1 and 1. So there are three equilibrium points are there. The three equilibrium points are 0, 0, second point is minus 1, 0, and third is 1, 0. So these are the equilibrium points. So this is a solution. Next is where to find determine state space representation for this system. System is given, this is a network. So this is E of T, voltage applied to this network. This is resistance, inductance, and capacitance. The current flowing through this is I of T, and the voltage across this is C of T. That is voltage across this capacitors. So let us consider this I of T and Vc of T are state variables. If these four state variables, apply A VL to these networks. So E of T is equal to R into I of T plus L into dit by dt plus this current flowing through this is the voltage across this is C of T. Okay. And second equation is for the current which is flowing through the capacitor, that is a C into dEc by dt. Okay, so as these are the state variables, we have chosen I of T and EC of dash. So we have to write there I of T dash is equal to dit by dt and this EC dash is equal to dEct by dt. Okay, so these are the two state variables. So we have to solve the above two equations, equation number 1 and 2 for these values. So dit by dt is equal to I dash of t. So we can write here L into dit by dt is equal to E of t minus R into I of t minus EC of t. So instead of this dit by dt, we have to substitute it of dash. So it of dash is equal to 1 by L E of t minus R by L I of t minus 1 by L EC of t. This is equation number 3, and we can write for equation number 2, and that is what is equation number 2? That is I of t is equal to C into d EC of t by dt. Okay, so instead of EC t of dash is equal to this. So instead of this, we can write here EC dash is equal to 1 by C I of t. Okay, now from equation 3 and 4, we can directly write the state space representation. So state space representation is IT of dash is equal to EC t of dash. This is a state space representation. Here the matrix, and second is the IT and EC of t plus this is a E of t. So we have to find the variables here in this IT of dash. So it is a I of t variable is coefficient is R by L. Then EC of t, it is a minus 1 by L. And now second equation, this equation, EC dash of t is equal to 1 by C I of t, and this value is 0 here. And in first equation, coefficient of E of t is there. This is 1 by L, and this is 0. So this is a state space representation for the given systems. Thank you very much for watching the video.